Right, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day to everyone. So we continue our discussion about equation of straight line. So this time we discuss about the examples. Right, so in example 1, so find the vector equation, parametric equation, and Cartesian equation of the line L which passes through point 1, negative 2, 3 and is parallel to vector 4i plus 5j minus 6k. Right. So firstly, we want to find out the vector equation. And we know that the formula for vector equation R equals A plus TV. So we have a two component, a point and a vector parallel. So given a point passes through, so straight away we got the value of A, that is 1, negative 2 and positive 3k. And then from vector parallel, we got V, that is 4 I plus 5j minus 6k. So straight away we substitute all this a and v into this vector equation. So we got the equation to be like this, right? So this is our answer for the first part, that is to find the vector equation. Right, so next we move to the second part to find the parametric equation. So from this vector equation, so we will replace r with xi plus yj plus zk. So after we replace r with this one, and then we will expand the right hand side. So we group together I, j and k. So it will be like this, right? Then after that we will equate left and right hand side and we form equation. So equate I, will get x. So automatically we got the parametric equation, okay? Because on left hand side it will be x, so x equals to 1 plus 40, okay, as you can see here. And then for y, so left hand side it is y, and then right hand side negative 2 plus 5t. So this is the equation for y. And then lastly for z, so left hand side is z, so we got z equals to 3 minus 6t. So this is how we find out the parametric equation. Right, so lastly, we want to find the Cartesian equation. So from this parametric equation, we will put t as a subject. So t equals to x minus 1 over 4. So same also for parametric y. So put t as a subject, so it will be y plus 2 over 5. So same also for z. So we put t as a subject, so we got z minus 3 over negative 6. So all of these are equate with t, so we can equate together. So we can equate together and we don't put the t. So we need to put t because Cartesian we only have x, y and z and no t. So that's why we don't put t at the front. Okay, so this is the answer for Cartesian equation. Right, next for the second example. So find the vector equation of a line that contains a point A and B as given here. Right, so remember to find the equation of the line, you should have a point and also a vector V, right? So a point we can choose either from point A or point B. So here we choose point A. But for find out B, so you have to find out vector AB. So AB we know OB minus OA. So from here we got position vector. So position vector OB minus position vector OA. So we got vector AB negative 3 I minus J and no K. Okay. So after we find out A and V here, then we can write down the equation. That is the vector equation. We know R equals A plus TV. So substitute A here. And then V from here. So we got I plus 2J plus 3K plus T in bracket negative 3I minus J on the K since K is 0. Right, next for example 3, a straight line L1 contains a point and is parallel to the y-axis. So state the vector equation of the straight line. So from a point, so we got A, that is 3I plus J plus 2K, and then parallel to y-axis. What mean parallel to y-axis? So what's the value of V? So since the parallel to y-axis, it means that you only have J. Okay, y-axis is associated with J, so they only have J. That is the value of J is 1. Okay, and no I and K, right? So in other words, we can write down also as a 0, 1, 0, okay, for V. And then from here, we can write down the vector equation of L1. So we know R equals A plus T, TV. So V only J. So we substitute A and also V, which is J only. That is 0, 1, 0. Okay. So that's our answer for example 3. Okay. Very simple. Next, for example 4. So find the vector equation of the straight line L1 that passes through point 0, 2, 3 and parallel to line L2 with vector equation R equals to 3i plus t in bracket 2i minus j plus k. So what's the solution for this one? So remember, for equation of straight line, we need a point and also a v that is vector parallel to the line. So for A, so we can find out from here, there is let's say here we put B, that is 0, 2, 3, and then so remember this is our line, and then the vector parallel L2 is here. So from here, this is the equation. So since it's parallel, so we can take this one as our V, that is 2i minus j plus k. So we can take this one as our V, okay? 2i minus j plus k as our V. So after we find out A and V here, then we can write down the equation. So equation, so this time is B and not A. So B plus TV. So substitute from point, so 0 to 2j, so 0 no need lah, so 2j plus 3k, and then from here V 2i minus j plus k. So this will be our equation for example 4. Okay. Okay, next for example 5. So a line has a Cartesian equation. So this is Cartesian equation. Remember, I already explained before. The Cartesian equation only have x, y, z and no t. We already eliminate t at the front. So find the vector equation of the line passes through the point with the position vector 5i minus 2j minus 4k. And then question 2, find the coordinates of the point on this line where y equals to 0. So first we find out the vector equation. So from the line here, it is mentioned that it's parallel to with this line. So remember, this is parametric equation. The Cartesian equation. So to play safe, you can change back into parametric and also a vector equation. But actually, we can find out V from here as highlighted in the yellow one. Why? Because if x, y, and z as a circle here, so if x, y, and z all positive, then the V component is in the denominator. So the highlighted, the yellow one would be our V, that is 3i plus 4j plus 5k. So this would be our V. And then the point given, right, position vector would be our A. That is 5, -2, and -4. So with these two information, we can write down our equation. So the vector equation of the line L2 would be, so substitute A plus TV. So here we substitute A, and then V from the vector parallel from the other line. So here we put our V. So this will be our vector equation for L2. Okay. Next, you mentioned about when y equals to 0, right? So first, from the vector equation, we change into parametric. So we got this one, our parametric. Okay. Right. So from the parametric, the question give y equals to 0, right? So y equals to 0, we sub into the parametric of y. So 0 here. So negative 2 plus 40 here. So we bring down here. We equate with 0. Okay. Because from here, we need to find out the value of t. So we find out the value of t is 1 over 2. So after we obtain the value of t, that is 1 over 2. So this t we substitute into the other parametric equation to find out the value of x and also z. Okay, so when t equals to half, we substitute into parametric s. So we got the value of x is 13 over 2. And we will substitute into parametric z, we got the value of z is negative 3 over 2. So from here, we can write down the coordinates when y equals to 0. So y is 0, the y is 0, right? So 13 over, so the point would be 13 over 2 from x, so 0 from y, so y is 0, and then from z, negative 3 over 2. So write down the bracket here because the answer must be in coordinate. Point must be in coordinate, okay, not in vector. So remember, don't mix up the vector with the coordinate, okay? Right, so now we move to the example 6 and the last example in this video. So in this example, show the line L1 with vector equation given here is perpendicular to the line with the Cartesian equation. So remember, the form of the equation is different. So you have to find out the V from L1 and also L2. So from L1, so the V is inside here, that is 2i plus j minus k. And then from L2, Cartesian, remember the previous example. So if x, y, and z are positive, so we take the V component is below here, that is negative 3 minus 2 plus 4, positive 4, okay? So this will be our V2, okay? So let's say for L1, V1, and from L2, V2. So, remember in the previous video, in the scalar product, how do we show the two vectors are perpendicular? Yes, we will do the same concept. That is, if the two vectors are perpendicular, the dot product, that is the scalar product, would be 0. So we use the same concept. We find the dot product or the scalar product. So V1 dot V2, right? So we know we multiply according to the XYZ. According to IJK. So 2 times 3, 1 times negative 2, and negative 1 times 4. Okay, so after we add up, we find out it is actually equals to 0. So since it is equal to 0, don't forget to write the conclusion. So therefore, L1 is perpendicular with L2. Okay, so that's the end of our example. Okay, so before we end of our video, so let's try to solve the exam this question. So the answer is given below here. So just one question, just to make sure that you already watched the video. So remember to give your answer in Google Classroom, okay? Right. So that's the end of our video. So thanks for watching. So don't forget, our next video we still discuss about application of vectors in geometry. So that is, we will discuss about angle between two straight lines. So stay tuned for the next video. Until then, thank you very much. Bye bye.